Hello everyone, and welcome to another homework solutions video. So first up, we're going to talk about question 5, which was problem 18 on page 616 of the textbook. A physics instructor wants to project a spectrum of visible light colors from 400 nanometers to 700 nanometers as part of a classroom demonstration. She shines a beam of white light through a diffraction grating that has 500 lines per millimeter, projecting a pattern on a screen 2.4 meters behind the grating. Now there were two parts to this question. A lot of people only answered part A and kind of forgot about part B, so we're going to make sure to go through both of them. Part A is how wide is the spectrum that corresponds to m equals 1. So when we're solving this question, the first thing we want to do is identify what type of diffraction we're talking about. And kind of the clue here comes in the 500 lines per millimeter. That suggests that we're working with a diffraction grating. So we're going to want to make sure when we do our math that we use our diffraction grating equations. So let's start by writing out what we know. So we have for red light, our wavelength is 700 nanometers. And then we know for our violet light, it's 400 nanometers. Now we're also given that there are 500 lines per millimeter. And that's going to be related to the distance between slits. That is not the number itself, but it's going to be related to that. Now, the last bit of information we're given is that our screen is 2.4 meters away from our diffraction grating. So we're going to have L is equal to 2.4 meters. So what is this question actually asking us to solve for? Well, we want to know the width of the m equals 1 spectrum. So ultimately what we're looking for is we want to know, and I'm going to use a double subscript, so y sub r1, so r means the height of the red fringe for m equals 1, minus y sub v1. That's what we're looking for. So we learned that y sub m is equal to L tangent theta sub m. We know what L is. We don't know what our angle is though. So we're going to have to use our other equation to solve out for the angle, and then we're going to plug that back in and get our y values. So on Wednesday we learned that sine theta is equal to m lambda over d for our bright fringes. So we're going to take the arc sine of both sides. We're going to have theta 1 is equal to arc sine of m lambda over d. Now we know what m is, it's 1. We know what lambda is in both of our situations. We don't know what d is, but we can find it using this information that we have. So if we have 500 lines per millimeter, that means for each millimeter we have 500 lines. So we can basically reciprocate this term, and that's going to give us the distance between our slits. So d is equal to 1 millimeter per 500 lines. Now this would be in units of millimeters, and I want units of meters, so I'm going to also do a unit conversion here. So we have, for every 1 meter, we have 1,000 millimeters, and this, if we go through and do our math, it's going to give us 2.0 times 10 to the minus 6 meters. So now that we know d, we can find our angle in these two different situations. So we're going to have theta r1, so the red angle for the m equals 1 fringe, is going to be equal to the arc sine of 1. Our wavelength is 700 nanometers, so that's going to be 7.0 times 10 to the minus 7 meters. And we're going to divide this by 2.0 times 10 to the minus 6 meters. Plug that into our calculator. So this will work out to be about 20.49 degrees. Now we can just go ahead and repeat this process for our violet fringe. So we're going to have theta V1 is equal to arc sine of 1 times 4.0 times 10 to the minus 7 meters divided by 2.0 times 10 to the minus 6 meters. And we're going to get about 11.54 degrees. So now that we know our angles, we can go ahead and calculate out what YR1 and YV1 are. So we have YR1 is equal to L tan theta R1. So this will be equal to 2.4 tangent of 20.49 degrees. This one works out to be about 0.897 meters. Now we can do the exact same thing for our violet one. We're going to have YV1 is equal to L tan theta V1. So it's going to be 2.4 tan of 11.54 degrees. And this will work out to be about 0.490 meters. Now the last thing we have to do is find the difference between these two. So we're going to take 0.897 meters minus 0.490 meters, which will give us 0.407 meters, or to 2 sig figs, 0.41 meters. So that's how you would solve part A. Now part B asks us how much distance separates the end of the m equals 1 spectrum and the start of the m equals 2 spectrum. So the end of the m equals 1 spectrum, that's going to be our red fringe, the m equals 1 red fringe. So that's going to be y sub r1. The beginning of the m equals 2 fringe is going to be our violet light fringe, the m equals 2. So we're going to have yv2 minus yr1. That's what we're looking for this time around. Now we already found out what yr1 is, so we just need to figure out what yv2 is. yv2 is equal to L tangent of theta v2. And this is going to be the same thing as L tangent of, and theta v2 is the same thing as arc sine of lambda over d. So I'm just kind of doing everything in one step this time around. You can do it individually. You could solve for theta v2 and then substitute it back in. But if you want to save a little bit of paper, a little bit of space, you can go ahead and do it all in one step. We found out before what our theta was going to be, and so we're just plugging that in here. And then we can go ahead and plug in our numbers and kind of almost finish the problem all in one step. So then we're going to have, this is going to be equal to, well, our L is 2.4 meters. Then we're going to have the tangent of the arc sine of, and now our m is 2. Our lambda is 4.0 times 10 to the minus 7 meters. And then d is the 2.0 times 10 to the minus 6 meters that it was before. And so if we go ahead and plug this into our calculator, we will get that it is equal to about 1.048 meters. So we're almost done. Now all we have to do is find the difference. So we're going to have YV2 is our 1.048 meters. And we're subtracting from this our 0.897 meters. And so if we go ahead, plug this into our calculator, and round to 2 sig figs, we're going to get 0.15 meters as our final answer.